Good morning, all. My name is Dr.E.Purushotham. In our previous class, in our waves and oscillations, I have discussed about wave and oscillation. So, what is the wave? What is the oscillation? I discussed. What is oscillatory motion? With examples in our previous class, we have discussed. In today's class, I am going to discuss about simple harmonic motion. What is the definition of simple harmonic motion? Types of simple harmonic motion. So I am going to discuss in our today's class. In our today's class, today I am going to discuss about this waves and oscillations. In this main topic, waves and oscillations, in this topic, the subtopic is simple harmonic motion, SHM. So what is simple harmonic motion? What is simple harmonic motion? Simply, you remember a formula. A is directly proportional to minus x. A is the acceleration, x is the displacement, negative sign is the a and x opposite to each other. So what is the definition? I am going to discuss what is the definition of simple harmonic motion. The simple harmonic motion is a periodic motion about mean position in which the acceleration of the body is directly proportional to its displacement from mean position and is always directed towards the mean position. You can see on the screen. You can see on the screen. So this is the simple pendulum. Simple pendulum. This is the center point. This is equilibrium position or mean position. So this is the end point or equilibrium point. So the simple harmonic motion is a periodic motion about mean position. You observe this is the mean position. So this is the mean position, this is the extreme position. The distance between this mean position to extreme position, it is represented by x, that is the displacement. So the displacement by time, that is velocity. Velocity by time, that is acceleration. The acceleration is directly proportional to displacement. And opposite to each other are always directed towards the mean position, that is called simple harmonic motion. So simple harmonic motion, in simple harmonic motion, just you remember this formula. So A acceleration is directly proportional to displacement. The negative sign represents that A and x opposite to each other, or it is always directed towards the mean position. That is the definition. The acceleration of oscillatory particle is directly proportional to displacement and it is always directed towards the mean position. Phenomena is called simple harmonic motion. Simply what I am saying, so this is O is the simple mean position or center point. Mean position. So from mean position to extreme position, that is displacement. This displacement and acceleration both are opposite to each other. A is directly proportional to x and always directed towards the mean position. Phenomena, that is simple harmonic motion. So in this figure you can observe this is equilibrium position. Equilibrium position. So this is maximum point. This is also maximum point. So this equilibrium position to maximum point, this is displacement x. You can observe in this figure. So this displacement is and this acceleration is opposite to each other. So A is directly proportional to x and always directed towards the mean position, that is called simple harmonic motion. You can see this is the simple harmonic motion oscillation. You can observe on the screen. So what is the definition? The simple harmonic motion is a periodic motion about mean position, in which the acceleration of the body is directly proportional to its displacement from mean position, and it is always directed towards the mean position. This is the perfect definition, but simply you can remember A is directly proportional to minus x. So the acceleration of the body is directly proportional to its displacement from the mean position, and also always directed towards the mean position phenomena is called simple harmonic motion. Simple harmonic motion. Types of simple harmonic motion. So depending on this path of motion, so it is divided into two types. Two types depending upon the path described by the body, or simply depending on path along a straight line, that is linear simple harmonic motion, or along a angular path. The body is moving around a fixed axis or fixed point, that is angular motion, angular path. Depending on this angular path, it is angular simple harmonic motion. The types of simple harmonic motion is divided into two types depending on path. So linear simple harmonic motion and angular simple harmonic motion. So what is the difference between linear and angular simple harmonic motion? You can see on the screen. So left side linear simple harmonic motion you can see here. So right side angular simple harmonic motion. So you observe clearly, linear means along a straight line path. Right side angular means around a fixed point or angular path. You can observe. If the periodic motion of the body or particle or an object is in a straight line path, then that particular motion of the body is said to be linear simple harmonic motion. What I am saying? The motion of the particle, the periodic motion or repeating motion of the body is in a straight line path, then the motion of the body is called linear simple harmonic motion. What are the examples of linear simple harmonic motion? So first one, vibrations of the tuning fork. Second one, vertical oscillations of a loaded spring. So one is tuning fork, another one is loaded spring. What is that linear simple harmonic motion? The periodic motion of the particle is in a straight line path, then the motion of simple harmonic motion is called linear simple harmonic motion. If a simple harmonic motion body is moving in a straight line path, then the simple harmonic motion is called linear simple harmonic motion. Another definition we can explain what I am saying. If a simple harmonic motion particle is moving in a straight line path, then the simple harmonic motion is called linear simple harmonic motion. What is angular simple harmonic motion? If the periodic motion of the body is in angular path, then it is said to be angular simple harmonic motion. That is simple harmonic motion. You can observe on the screen. In this case, the displacement of the body is with respect to angle. Some small angle, that is angular displacement. So if the simple harmonic motion, another definition, if the simple harmonic motion of a body is in angular path, then the simple harmonic motion is called angular simple harmonic motion. Angular simple harmonic motion. What are the examples of angular simple harmonic motion? You can observe two examples. Motion of a freely suspended magnet in the earth magnetic field. Another one, oscillation of a torsional pendulum. Oscillation of a torsional pendulum. So here we can also give one question. What is the differences between linear simple harmonic motion and angular simple harmonic motion? The main differences. So first one, the linear simple harmonic motion is in a straight line path. Angular simple harmonic motion is a angular path. So these are the two examples. That is linear simple harmonic motion and angular simple harmonic motion. If the periodic motion of the body is in a straight line path, that is called linear simple harmonic motion. If the periodic motion of the body is in angular path, then it is said to be angular simple harmonic motion. So linear simple harmonic motion example you can observe on the screen. Vibrations of tuning fork. So these vibrations are moving along a straight line. You can observe here clearly. Along a straight line. You can observe here. Vibration of the tuning fork. Example, vibration of the tuning fork you can observe. So it is moving along a straight line. The periodic motion of the body is in a straight line path. So this motion is called linear simple harmonic motion. So another one you can observe here. This is the torsional pendulum. So it is moving with some angle theta m or minus theta m. So what I am saying here, you observe here, in this case the displacement of the body is with respect to angle. You can observe. So this is angle theta m. Here also this is angle theta m. That is oscillation of torsional pendulum. Oscillation of torsional pendulum. These are the main differences between linear simple harmonic motion and angular simple harmonic motion. If the periodic motion of the body is in a straight line path, then the simple harmonic motion is called linear simple harmonic motion. If the periodic motion of the body is in angular path, then the simple harmonic motion is called angular simple harmonic motion. So thank you one and all. Thank you very much.